Okay. Okay, we're back. Lorica, are you in a restaurant? Are you in a restaurant? It looks like Cafe de Coral.
Yeah, I'm in a Starbucks.
Starbucks, okay.
Because otherwise I would be too late.
Okay.
Too much traffic.
Okay, no problem. Okay, I see Oscar, Rebecca, maybe.
Hello.
Somebody wants to be trained?
Hello.
Yeah, me.
You came back. You're back. You're here. Excellent. Okay, so let's resume. Okay, so we're here. Okay, so everybody tried to play the game. And so now we're going to watch another short movie explaining how it actually works under the hood. So, sorry, I don't think I'm showing my screen. I need to check if I'm showing my screen. Share my screen. Share my screen with everybody. Okay, here you go. Okay, everybody see my screen now?
Yeah.
Okay, good. Nope, this is not the right window.
Hi, I'm Jonas. I am Henry. Draw is a game a few of us at Google made. You draw and the computer uses machine learning to guess what you do.
I see square, or suitcase, or canoe. Oh, I know, it's shoe.
An experiment that uses some of the same technologies that helps Google translate, recognize it. To understand handwriting or drawings, you don't just look at what the person drew, you look at how they actually drew it. Which strokes did they make first? Which direction did they draw them? Train the computer on millions of characters, hundreds of languages, and over time, it learns whether you wrote look or whether you wrote look. Training is a big part of how the computer can guess your drawings correctly. As people, it's easy for us to look at these three drawings and know they're all pens. To a computer, they're very different. One is just a head, one has a full body, and one is just facial features. For the computer to understand, you have to show it a lot of cat doodles. Then start with patterns, like that almost all doodles of cats have pointy ears, small nose, and whiskers. Of course, it doesn't always work. That's because it's only a few thousand doodles. But the more you play with it, the more it will learn, and the better it will get at guessing.
Oh, I know, it's cat.
We put it on the web for anyone to play with. We hope it inspires other people to think about fun ways to use machine learning. You can play it at g.pro/AI experiments.
Okay, so let's just have an insight. So it tells you about the system that is behind. Somebody needs to mute because there's a sound to have quite a big echo. Is it somebody in this room? Okay, seems that it's okay. So we're going to be building our first AI set. So we're going to be learning how to differentiate different objects. So you're going to go onto your browser, and we're going to simply do a search. And the search you're going to be looking at. You're going to be looking at teachable machine with Google.com. Teachable machine with Google.com. And so what we're going to do is that we're going to be training the computer to recognize different things. And so we're going to be creating first data sets. Second, we're going to learn how to train that algorithm. And second, we're going to actually compile the program and actually run it. Okay, let's do that. So we're going to click, are you all on that page? So if you refer I'm also going to put it into the Design Plus group and into the Dream Team group. Okay, so you should be on that page now. Yeah, everybody's on this page?
Yeah.
Yeah. You don't have a computer. Okay. Okay, so we're going to press on Get Started. And then the type of training that we're going to be doing today, we're going to be starting with an image project. Yeah. Okay, so this is the first machine learning program interface that you're going to be using. I'm going to ask you to grab 2 objects in your environment and 2 objects that look quite different. So for example, right in front of Michael, there's a blue mouse. You also have like a blue triangle behind. Just grab 2 objects that look quite different to one another and that are manageable. They can be within the, one object can be a face and it could be a bottle. So that could be 2 objects. One can be a bottle and the phone or your mug. Or can you grab an object around here? You can take a tool, for example, you can take a hammer, a saw, pliers, a 3D prints. Yeah, perfect. Very safe as well. Okay, excellent. And so I'm going to make a demo. Let's say I'll do the demo with this book because I think it's so I'm gonna hold the book in front of my webcam, and here I'm going to use the webcam right here. And you can see that when I press webcam, it opens up a little dialog. So think about it this way. The computer doesn't know that you're showing it a book or my face. If you show both at the same time, both the book and my face, he might perceive my face and the book as being one object. And you would see that if I take multiple pictures, the background is also part of the information that I give to the software. So if the background is not changing, or if in the future I move my computer a little bit and the background has shifted, then you will take it as a difference in information, right? So ideally, so you guys have the best position. If you want to drop down the curtain a little bit more, you could have a white background. So if you drop down the curtain even more, that means that when you capture, if you orient the screen on the white background, then it's going to recognize this object in the white background, and that would increase the ability for the software to recognize that particular object. Okay, so I have a noisy background, so that's going to be a little bit of a handicap, but I think it should still work. So I'm going to hold the book. Instead of being my face in the book, I'm just going to make sure, in my case, that I'm going to hold the book here. And here, so the trick here is to press on the hold the record button, but I will keep pressing, not just a click. I would actually stay pressed down. So I will show you how that works. So I press, and you can see I'm going to spin the book around. And it's taking pictures. Here I've taken 103 pictures, so it's basically like 25 images per second. So just in like 3 seconds, I've taken 103 pictures. So I have just created the data set of 103 source images. And I'm going to call this I'm going to just go here, and I'm going to call this the robotics book. And I'm just going to save that. Okay, and then I'm going to take another object. Let's say this thing, a pair of red scissors. And I'm going to go here, and I'm going to name it red scissors. And I'm going to go on the webcam. And I will do the same thing. So I will put the scissor well in the frame. And I will hold the button. And I will just take the scissors and rotate it in different angle. Okay. Okay. So now I've created 2 data sets. One is 103 images. The other one is 90 images. And so that's already a set. So don't go over 200 images. If you can stay in a range between like 30 images to 200 images, that's a good idea. If you put too many images, you might make the rest of the process too slow. Okay. And so everybody is there? Oh no, you're still training your sets. So Erica, what is the object you are training? Your phone, okay. Make sure that the image doesn't flicker. Rebecca, what is the object that you? What are the two objects that you have?
I'm using my cup and my phone.
The cup and your phone, okay.
Yeah.
So don't be too close from the camera. You want to have the objects kind of within frame. You don't want the object to go out of the frame.
No, we just record it. It's like a video, but it puts it as pictures.
Okay, so everybody has built those two sets.
Yeah, I only got one set.
I have a problem that my computer said there was an error opening your webcam.
Yes. So some issue may arise because if you have, it depends on the version of your computer, but sometimes if you have multiple applications using your webcam, there may be conflicts. So it's possible that that the browser is trying to access your webcam, but your video conferencing. So maybe what about you try to turn off the camera of Zoom, the video conferencing, and like this maybe and then maybe refresh the page of Teachable Machine and try it again. So turn off the camera for the meeting, but turn and refresh the Teachable Machine with Google.com train image. So when
It doesn't work.
Doesn't work?
Yeah, maybe your browser doesn't support it. So if you go in Google and just look for Teachable Machine, just search for that. Don't go to the URL. It will tell you whether your browser is supported or not.
Good for webcam is doing it.
Webcam is
Yeah.
So the settings for the webcam has to be changed.
Could
So
be.
may be able to access Teachable Machine, which is the webcam is like the system.
So I would say if you cannot work this exercise, it's okay because there's many more exercises coming. So I would say if this doesn't work, don't worry. Just really follow the class, and then you can after the class is finished, you can try it again on your own. The slides are shared as well. We have questions. You'll be
So
able-
I have to leave. Apparently they're closing the Starbucks I'm in. So yeah,
Okay.
I'll try and call later.
Bye.
Bye-bye.
Okay, everybody has built those two sets. Okay, so now you're gonna go. You can go into the training tab, and you can see here there's an advanced tab here. But before I explain what this does, I'm just gonna ask you to make sure that the values are that. So if you don't change anything, they should be that by default. So they should be 50, 16, and 0.001. And don't change this value quite yet. Just leave this value now. Perfect. So if they're not that, please reset to default. Yeah. Okay, and I'm just gonna click on train the model. And so as you train the model, there should be a progress bar. But what this is doing is that it's basically taking all the images and transform it into a resources to differentiate those two objects that you have tried to put in there. And so then after a few seconds, you will have on the right side, you will have the image that you're filming. And it's trying to guess if it's the robotics book, which is this orange book in this case. So it's recognizing it. And then if I show it the other object, the red scissor, it recognizes the red scissors. You see? So if I bring the red scissor in the picture, you see at the bottom, it tells me how much confidence it gets to actually recognize the object. Yes.
So when we are taking the image, if we don't turn it down, we could just show it like this.
We will only learn that side of the object.
And then we show it like this, and it will not recognize, or it will recognize with less confidence.
Possibly
We can try
recognize
that.
with less confidence.
We can try that.
Because, for example, this object is not only the shape, it's also the color.
Yeah.
It's also the size. So sometimes,
How it appears.
yeah. So there's a lot of information. Exactly. And if you show the two objects at the same time, then it's not confused. It's basically telling you that it's alternating between the two objects, right?
Oh, okay. Yeah.
What?
But shouldn't it be showing 100% for both?
Yeah.
Showing two together.
There you go. It's because my face was inside of the frame. I think it. Because I think in my set here, I have my face. So I'm going to re-record it and then retrain the model. Because my face was somewhere in some of those pictures. I think that's what is causing it to. So I'm going to do less image per second. I'm going to do like 10 images per second, so I can get more. And I'm just going to clean. I'm going to remove all my samples. And I'm going to do. I mean, it's definitely so fun to
Caesar,
yeah.
put something else in front.
One second. So now I'm just going to retrain my model. So now I have built a better data set. I have the lower frame rate, and like this, I could take pictures in more angle. And so I'm retraining it, and hopefully this time it should be
After
better.
you retrain it, can you show something else and see what happens?
Of course, yeah. Okay, so now my scissors now should have a better accuracy, yeah, much better. Because the pictures I've taken of my scissors are better. So now it's oh. I guess my face is kind of part of recognizing the book. Yeah. So, okay.
But why is it when you show the book and the scissors?
Yeah.
Wouldn't it be showing 100% for both?
No, because this particular algorithm is a classifier. So you could have a classifier which is trying to really differentiate. You have another algorithm which allows you to just identify a specific object, and some of them create the bounding box. So when you look at documentaries about like AI, sometimes you will see like those like really fancy block, and you could see like you could recognize 100 people at the same time. But in this particular exercise, it's just one or the other. Yeah, that's the output is just single output because it's a single output NN. And so everybody has got that. Rebecca, Anson, Anson is in this room. Oscar.
Yeah.
Matthew, does it work?
Yeah.
Okay, awesome. So
But did we try the not?
We're going to do that in the next exercise. So, but before we go into that, which is adding more complexity, I just wanted to see first two objects, classifier, and then we're going to go into more complexity, and we're going to go under the hood and try to understand like what is actually happening. So before we do that, I just want to show you as well this, click on the export button, please. So if you can click on the export button, and you're going to see there's actually 3 tabs. The first tab is the Tensorflow.js, and JS stands for JavaScript. And JavaScript is a very common programming language with which a lot of web app or web interfaces are being built, and a lot of software is being built. Which means that this makes TensorFlow, which is the kind of the algorithm that runs behind it, to be portable and to be portable to the web. Which means that you could basically, and I'm going to show that in a second, we could basically copy that code. We could build a web page, and you could actually make a website from your website, for example, that actually recognizes the type of visitors that you have. For example, you could make a website that can see from the face if it's a male or female visitor, or the shades of skin of the people that are getting on your website. You could actually see all this information based on just like a few thousands of pictures that you put of people. The second one is TensorFlow, is here. So the second tab is TensorFlow. And what is TensorFlow? TensorFlow is the algorithm that runs behind. It's not the database, it's the infrastructure that runs behind. And so that means that you could basically, you have built a small data set, you could download it, and then you could continue to tweak it on your computer, on the TensorFlow framework. And the last one, which is the TensorFlow Lite, is basically TensorFlow. So that's the Google AI API and suite of software. But that allows you to run it on a very small device without a connection to the internet. So once you have trained your AI, you don't have to have it connected to the internet. Like those two ones, this one is web and this one is on your computer but connected to the internet. This one is TensorFlow at what we call the edge, which means it's TensorFlow but on a device, on a portable device. That could be a phone offline, or that could be a computer, which I'm going to be demonstrating here afterwards. So I'm not going to ask you to do that, the next step, but I will just demonstrate to you how easy it is to build like a portable web app. So I'm just going to build a web app just in a few clicks and show you how you can build a web app that has AI and computer vision built in, and it's the most basic web app that you could build with an AI. So I'm gonna go in Tensorflow.js, and here I'm gonna go into download. Upload, and I'm gonna upload my model. So now I'm uploading my model, and here you will see that the HTTPS teachable machine is gonna create a short link. You could actually try to edit the code online. So instead of writing on my own machine, I could just try to have a preview here. So this is the software that it's outputting. So it's the classifier URL, and it's basically, you could create a simple page that calls a lot of content from Google AI. Instead of downloading the whole library of AI and the whole software, you could basically say, I'm running a JavaScript on one web page, and that JavaScript is calling the power of Google. I'm summoning the power of Google on my page, if you will. And so if you compile it, this is how the page would look like. You could have the machine here, and you could see, for example, here daytime or night. So the software that is loaded now is just to say daytime, or if I block the webcam, it says nighttime. You see, daytime, nighttime. You see the text is changing under the image. So this one recognizes daytime or nighttime, but you could also load other software that you want to. For example, like detecting red scissors or the book. You could do that. So now I'm going to show you how I could have the book example. So to get the book, what I would do is that I would download this one. Is it this one? Load my model. I forgot if it was this one or this one. HTPU or Keras. I think it's this one. AT. I built a sample. I just want to check. I'm just gonna show to you like what I have built. Was it this one? Okay, I'm not entirely sure. I don't want to waste the time, but basically the idea is that I could just copy that code, put it on a website, and run basically this train set. And what is amazing about it is I don't have to upload the hundreds of pictures, origin pictures. I don't have to upload the whole set. What what the machine has done is that it has learned how to recognize it. It doesn't need the source images anymore. So let's say if I want to recognize Fergal's face, I don't have to train. I would need thousands of pictures of Fergal's face. But once I have trained my NN, then I don't need to upload thousands of pictures of Fergal's face online. It basically recognizes Fergal's features, and that's good enough. So let's say if I have 1 gigabyte of Fergal's picture, I will need those pictures to train the neural network. But once I have trained my neural network, it may be only like 5 megabytes, and that's largely enough to run the whole program. Okay, so going back to the presentation here.
Are you saying it doesn't store those images?
Exactly. So for example, let's say if I want to recognize 1.2 billion Chinese people using a webcam, I don't need to have say 10 megabytes of pictures of each of the face of each Chinese person. Like once I have recognized a Chinese person once, then actually it's good enough to continue to recognize that person as part of a broader data set.
Okay, so basically they capture some data points on the face so that they recognize it as unique.
And it does this by like consecutive approximation. So it's if you have a human being, you're gonna have recognizing 2 eyes and 1 nose, and it's gonna be typically measuring the distance between those like recording points. And there's a lot of tolerance. And so it means that if a person becomes aging, for example, one day you wear your glasses and the other way you don't, there's a lot of tolerance around that. And if a person disappears for many years, that might be a problem though, because then the person will have changed, and then you will have to reconnect those data sets. But once they are reconnected, then you will be Okay, so you have just built a first classifier. To answer to your question, you could easily add a third category or a fourth category. You could easily add 100 more pictures per images. And if you went back, you could also increase the learning rates. So I'm not going to go into the details of it, but basically what you can do is that once your network is set, you could say, cool, I want to not run 1 million cycles of training, but I want to run 10 millions. So you could have the same data set, but if you just give it more time to run more iterations, then your learning network is just going to become more and more accurate.
How does it know what's the central picture, the theme that you're trying to? For example, it could be a T-shirt or you. Because when you move,
It doesn't know.
It doesn't know it. So
Yeah.
how does it recognize that it has to? Yeah.
So if I go, deeper into the way the neural network analyzes an image, so it's going to be different from a sound. It's going to be different from, say, from a position. So for example, the way you recognize an image is just that it converts. First step, it converts a high resolution image into actually a low resolution image. You'd be surprised actually most neural networks actually compute just not thousands of pixels, but just a few hundreds. So the way it does that, then after each of the image of the pixel, we have pixels, and those pixels typically are not even kept in color. Typically they're converted to black and white. So that's the first. And then into black and white, they actually reduce the resolution of black and white and to grayscale. And they're trying to reduce the bandwidth of grayscale into 256 levels of gray. And so now, instead of having an image with millions of colors and thousands of pixels, just have a few hundreds, and now they are gray. And then after that, they're going to be typically looking for features. So they're going to be looking at the contrast between two adjacent pixels. So they're going to be looking like you have a clear pixel and a black pixel. And then from this, they will draw what they call edges. So that's an edge detection algorithm. So first, they reduce the amounts of data and simplify it by a simple like visual signal. And then they try to compress the signal to try to make it more digestible. And then you get this very, very low res image that a human being could never actually identify a face from. Actually, the computer, because it's taking into account thousands of those gray sets and amplified contrast and edges detection, it's actually able to make sense because you just have a quantity of image. It's very abstract, so what's happening is that then it creates like a relationship between the pixels, and that relationship is, I mean, if you look at the code, it becomes gibberish. So for the longest time, actually, in the field of mathematics, like computer vision, computer learning, machine learning, was looked with a very negative eye. People are thinking, this is really like a black box. They're thinking, I am putting some high-resolution image, and it's giving me some gibberish code. And sometime at the beginning, they were accidentally just recognizing faces and complex objects. And eventually, they found how to weight each priority. So this is becoming more complicated, but basically, like once you have a low-resolution image, and you start to have multiple angles of and you still say, you train it, and you say, if you see this gray, and you see those contrast value, that's Michael. If you see this other set of lighting on Michael's face, it is still Michael. But basically, if you build thousands of these of inferences, eventually the computer would say, oh, I get it, this is Michael with very different types of lighting. And if it's somebody else, so the computer will recognize, but it wouldn't recognize Michael as Michael. It would recognize that those mathematics, those data sets. It recognize, oh, the closest data sets that I've seen that look like that, I was told it was Michael. And so over time, it will learn to recognize Michael better.
It could just be another guy with a beard or a big nose.
Exactly.
Which is what happened with Chinese software. Right? It's not so good at recognizing Western faces.
So for example, I have a friend from Iraq, and we have a very, very similar face. And Facebook, for 6 months, believed that we're the same person. So we consistently tag me or tag him, and we just mix over time. But the software has become better, and I almost never mistakes. It's possible that it's also looking at our social network. So not only from the images, because we look identical, but it's looking at who's potentially tagging us.
Did you correct it once?
Yes, I did. You're right. I also corrected it a couple of times. So it's possible that now it's just increased the number of cycles of training on our particular data sets. So I don't know what they do in the background, but what I can tell is that the software has really improved. Yeah. So I was mentioning that now that you have built this first train, this is very important you follow this because it's going to be part of your homework. You have to basically build something that recognizes objects, and you'll have to bring it to either the web or a device or an IoT device. Ah, that was that. So that was the piece of software that I wrote that basically I could take the data set that I've trained just using what we have done now. I just wrote a simple HTML page. I copy pasted the code in the JavaScript code in my page, and I published it online. And now I could basically have a web page that recognizes if people coming to my website having a blue bottle or red pair of scissors. It's useless, but it shows you that you can actually do that in a matter of clicks without knowing much programming, just some HTML, some CSS, and a tiny bit of JavaScript. You could actually build something like that. So I was mentioning Facebook example. So that's exactly what Facebook has been doing in the last few years. Now I think they're doing less of like face tagging. What we've been doing is really, so when you're asking me more about the details, and what I explain to you is mostly coming from this article. So if you want to learn more about the specifics about grayscale and edge detection and mass like optimization, you could do that. And I just wanted to also show you very briefly that I just showed you this example. But actually, if you go back to Teachable Machine, so we've just trained an image, but actually you could also recognize a posture. So you could actually say you could do like YMCA, you could do that, and you could recognize knots. So you could recognize a person's posture, or you could speak to the machine. For example, you could speak to the machine, or I could speak to it. And actually, we recognize the different voices of different people who are there. So I will ask you to play with those ones because that's going to be part of your homework to like create a data set and train on a set. Okay, so how now that we've looked a little bit under the hood, I'm going to demonstrate to you a edge machine. So I showed you different sets. You could do a set that's going to be ported on the web. So that was the Tensorflow.js. I talked to you about the Tensorflow that you can basically take a set and train on your regular computer. And now I'm going to show you an example. We built a machine that you can actually, that is here, that you can actually build a dedicated computer to run an AI algorithm. So I'm going to demonstrate to you about this. So there's this thing called the AIY, so Artificial Intelligence Yourself, which is a kit sold by Google, which you can buy in Hong Kong off the shelf. You can go in Avenue Street in Shamshipo, and they sell actually this kit. It costs, I think, 800 Hong Kong dollars. And there's a computer, there's an AI chip, there's a camera, and there's a bunch of other sensors that you could get. So I bought that kit. And it's a dedicated machine for computer vision, machine learning, artificial intelligence. So this is the kit that it comes in, and these are the parts. So you have the most important part here. So this is a Raspberry Pi. This one is the Raspberry Pi WT0, and this computer costs $5 US. So this costs like 40 Hong Kong dollars just for the computer. But the part that is more expensive because there's a much smaller size of production, that's what we call the bonnets, the vision bonnets. So that's the part that Google really developed. And this one is basically an extension of the computer. It's basically a graphics card. It's a dedicated computer vision chip. And then you have the strips to connect to the webcam. So that's the webcam. Somebody's mentioning. Okay. So that's the webcam, and the rest is basically a big button buzzer. This is a small light to tell you that the camera is filming. So if you are in your house or you don't have much clothes on, it will tell you. And this is a buzzer that you are hearing right now. So what we have done is that we have built this system, and then we had to then install a new operating system. So this Raspberry Pi here has a small it has a SD card inside of it. And so basically you have to install an operating system. So to install an operating system, we had to use Balena Etcher, which is basically a way to flash the card. So basically you get an OS from Raspberry Pi, and then you write it on the card. So yeah, so this is the build. So follow this instruction. And so now I'm going to show you how I'm going to get inside of this computer remotely. So now I have built this computer. I'm going to enter it remotely through the Wi-Fi. So that's a bit more tricky. So now I have this basically brain and like visual cortex, and I have the eyeballs, I have the eyes, and I have the voice. So like a human brain. And here I have the hands. I have an actuator. So the robot can not only look at stuff, it can also like communicate and speak. But I want to get into the back of the brain of that robot. So I need to get inside of it.
So what you did was you just took the kit and assembled it.
I just assembled it. Exactly.
So that's the starting point.
So what I'm going to do now is I'm going to go inside of this computer and try to control it remotely using an SSH command. So I'm going to try to go inside of this AI computer and try to change and run different programs on it. Yeah. So the first thing I need to do is I need to figure out how to speak to that computer. So it's basically, the reason why I don't go too much into detail is because this is essentially what you have already built. It's already your computer, basically. So I don't want to walk you through the steps of building that kit. I don't think it's super interesting. What I would like to show you is how one computer can get into other computers and control different AIs with a single computer. You could actually control many computers remotely. So the first thing is I need to figure out a way. So right now, the only thing that I'm providing, I'm not connecting data. I'm just providing 5 volts from my computer to this other computer. The only thing, there's a cable, yes, but it's just providing electricity to it. So the first thing I need to do is that I need to connect this computer to the internet. For that, there is actually a, where's my gray couch? Yes. So this computer, there's a kind of a hack to connect it. For that, you will need an Android device. So iPhone won't work on this. So I unlock my device, and I had to install a software that can communicate with that particular computer, that can connect through Bluetooth. So I can actually set up parameters remotely. So the first thing I'll do is, okay, so first, I'm going to go back into the setup. So I downloaded this application called on the Android app market called the AIY Vision Kit, which is the software that can set some parameters on this device. And so the first thing that I need to do here is to connect this to the Wi-Fi of this room. So what I do here is that I go into my settings. The first thing I go to the Bluetooth. And so here I want to be connected to not Megabase Central 5G, but Megabase Central, just Megabase Central. So I'm connecting to Megabase Central. I'm connected to it. So now this device is connected to the internet. So that's all good. That's all good and sweet. Then the second, I need to make sure that this device has Bluetooth enabled. And now I'm going to go into my Bluetooth settings. And here there's a Bluetooth pairing system. So there's a button on this. I'm going to click it. And then it should blink after a few seconds. And that means that it's going to enter pairing mode. Okay, the green light is blinking. I'm going to connect to it. So now my AI computer is trained to connect to Bluetooth. So I'm trying to pair it. And say, OK, I'm ready to pair. It's turned pairing mode. And now it's pairing. So now it's looking for my AI kit. The green light is blinking. It's trying to connect to it. Hopefully we'll detect the presence of that device. It doesn't seem to detect it. maybe I had to go first in the settings, maybe in the Bluetooth, and try to connect it manually, or try to detect it in the list of available devices, perhaps. If you have a wireless headset, please disconnect it now, because it might interfere with, okay, AI Vision Bonnet. Okay, I'm scanning for the Bluetooth device. Hopefully it's gonna see that it's there. Okay, I'm gonna go back to the app. I don't see the kit. I'm gonna try it again. Or maybe I will unpair it and then just do it again from scratch. Okay, oh, here we go, available device. Bluetooth, available device. So I'm scanning. Okay. I don't know why it's so slow to scan. Just restart the process. Hopefully it will detect it. Ah, looks like it should be this one. Here you go. AY Bonnet. So I'm trying to connect to it. Here, Vision Bonnet. Okay. Okay, so now it's detected it, and now it's gonna ask me, okay, you are connected to the bonnet. Now I'm gonna use this device to give the bonnet the Wi-Fi password. So I'm gonna tell the bonnet, cool, you're connected to my mobile phone, and I'm gonna tell you how to get on the broader internet. So I tell you wanna be connected to Make-A-Bay Central. The password you wanna use is just Make-A-Bay. I'm gonna show the password to make sure it's correct. Okay, I enter. And after that, it should blink solid green. And it should tell me basically now, okay, I understand my place in the world, I'm connected to the internet. Why is this step important? Is because you can only connect from this computer to this computer through the internet. But we're not going through the broader internet, we're just going to this sub router. We're just going through this local router. Okay, so now it's telling me that I'm connected to Wi-Fi through the Wi-Fi SSH Make-A-Bay Central. And I'm going to continue. And this is the reason why I've been doing this, is because I need to know the exact name of this computer or the address of it. And the address that I need to write down somewhere. And I'm going to write it here. I'm just going to open a new tab. I'm going to write the IP address. And my IP address is 169.254.140.167. Okay. And this is super important. And everywhere where you go, it's going to be different. And you're going to have to run the same kind of address finding process. So now I have this address. So that is done. Okay. So now I know the address of this computer on the network. I'm going to establish a connection between my computer and the AI kit. And to do that, then I need to use an SSH key. So what you see all the hackers do is basically what I'm going to do right now is I'm going to break into this computer remotely. So for that, I had to install another tool that is an SSH command line that connects through an IP gateway. So what I do is that I am going to open a new browser tab. And here there's a small tool that does a SSH, which is an SSH gateway. So you can download this. This is a Chrome extension. You could also run a dedicated SSH command line on your, or terminal, if you're good with terminal. And what I'm going to do is I'm going to give my computer browser, I'm going to give it the address of the computer that I'm trying to get into. So this looks like a terminal key at the back because it is basically a terminal, but just through the browser. Just make it easier for me to enter. So the name of my computer, I named it before. So when I set up the parameters, I called it just PI. And but I have to give it an address. So here I'm just going to copy paste the IP number, name PI, I'm going to make sure that the address is correct. There's no identification that I'm going to give for now, and I'm not going to give any extra arguments. So I'm just going to try to connect into it. So now basically I'm trying to get into this computer. So it's trying to get into it's trying to get into this device right now. Hopefully it works. I've tested it a couple of times. Hopefully there's no special encryption here that will prevent it from loading in. Or do I have another window? Okay, maybe I need to close my previous. So that should be okay. I'm just going to close other stuff that I was doing just to make sure there's no conflicts.
Why would we want to program an external computer?
So the reason why I show this is because, of course, you could use a full-size computer and run an AI, but that means that you would have to mobilize your computer to run anything. You could also run AI onto your mobile phone, and that would be all fine and good, but that means that every time you do something with AI, you would have to mobilize a mobile phone, which is an expensive device, right, and connect to the internet. The reason why I want to show you how to do this on a $5 computer is that if you have a $5 computer and a USB power socket and a camera that's like another $5, that opens up a whole new world of, if it's $10, you could actually connect to you could actually embed this AI into a lot of the projects that you want to do. Let's say you want to make a chair that can recognize who's going to sit on it. Then you can embed an AI inside of it. You want to make a vehicle that's going to go and fetch for the color red into the street. Then you could actually embed AI onto a device. It could be as small as this.
Program that, you will still need a computer, but once it's programmed,
it can stand alone.
Then you can make it stand alone, and it's like just having an Arduino or something.
Exactly.
And not really carrying a computer everywhere.
You could, of course, like it's just this is just a way that is portable, and that allows designer to embed very complex programs in a very small packages at a very low price point. If we're teaching computer science, 70 years ago, then you would have to have a whole factory to teach computers. But now you can teach computers just using a phone, right? And so just that leap in technology makes the technology more democratic. What I'm trying to show to you today is that for like $100, even if you don't know how to code, you could really connect and make something that stands alone, that functions. Yeah. Okay, so it looks like now connection is refused. That's embarrassing. So I'm just gonna reinitiate another connection. I'll try something slightly different. There shouldn't be problems in this part. Did I make a mistake in the address? Or it doesn't recognize it? So 169.254.140.167. Okay, that is correct. Okay, so I'm just going to try again. Connection dialog. So pi. That's the same. Server relay, identity no, import, enter. Or maybe I will have to connect to a different Wi-Fi network. So every time I would change network, basically we change the route. So we change the address. So that might break the connection. So I hope this doesn't happen. Or maybe because I'm connected to the USB, maybe it's believing that I'm trying to connect through the USB port. Maybe that's another reason. Port scan, maybe I can do the port scan. Sorry that happens when you work with this sort of app. So I'm gonna try to find, so these are utilities, trace right center host is down. Oh. Okay. That is interesting. Sorry about this. I don't know why maybe I changed to a different Wi-Fi. Am I on the subnet? Is there like a secondary router here? It should be straight to the. It should be straight to the router. Oh, there's a secondary router. So I might be under a mask. Okay. So I'll try to connect to the other one, maybe the 5G. I'll try to connect to the 5G network. Maybe it will be, because the 5G has got to come directly from the Makerbay Central 5G. So I need to figure the IP address again. Okay. Sorry about that. Vision kit, connect, continue. So I have to repair it again through the Bluetooth and find the okay. Well, it was much faster to find this time. Makerbay 5G. So I need to connect it to the other network this time, because I want to connect through the same router. But maybe it doesn't have 5G. No, the problem is that this chip doesn't support 5G. Only support 2.4 gigahertz, not 5 gigahertz. So that's not gonna work. So we'll have to stick to the original Makerbay Central. Okay, I have to stick to Makerbay Central and just hope that this time it's going to work with a new IP assigned. Okay. My connection is unstable. Okay, I'm connected to, okay, so it has assigned me a new IP address, so hopefully that will be better. 192.168, that looks better. 168.1.57, so that's my new IP address. And I'm gonna try to connect through that. So enter the SSH, connection dialog. So that should be pi at 78, try to enter. Oh, here you go. Okay. Okay, that looks better. Okay, so it's going to prompt me to enter my password. So I'm just going to make it bigger so you can see better what's going on. Okay, so I'm in the shell, and now it's asking my password. In this case, I can tell you my password I set is raspberry. And now it's telling me, cool, I'm going to start to run Linux and Raspberry Pi with this version. And this was the last time it was open. This is the time my system was built, and this is the last time I was logged in. So SSH is enabled, and my password for the Pi, I haven't changed my password. So it's just telling me, cool, welcome back. This is the last time we saw each other. What do you want me to do? And so it's prompting me with the command. So it's going to ask me, hey, what do you want to do here? The first thing I'm going to ask to do it is I'm just going to ask him to make a list. I'm just going to say ls, which means list in Unix command, and it's going to tell me, hey, these are the different things you have in this directory. So basically, this is the equivalent of your desktop. So this is telling you, instead of having a desktop, if I type ls, it shows me this is what you have on your desk. This is the list of things on your desk. And you can see that there are some AOI projects. So these are the preloaded example. There's an AIY voice kit command package here. There's some documents download, MacPy model, and there's a track.py, which is a program that we wrote with a friend of mine. So I'm going to demonstrate to you the very first program. It's already running. So this is the camera here, and here you can see there's an LED, and so right now it's black, right? But if I'm going to film Chiki's face, and now Chiki, if you smile, can you show your teeth? It should become yellow. If it can see your teeth, it should become yellow. Yeah, maybe a bit too far. Yes. Okay, so this is a smile detector. and then you've seen it turns yellow, and eventually even a little beep. So it means like, okay, 100%, I know this is a smile, 100%. And so then what you can do, you can press on this button, and this will take a picture. So basically, you can recognize a smile, and every time you have a full smile, you will take a picture. So that's the first by default app is trying to run. Okay, but you remember in class we have done this exercise where we 2 weeks ago we were learning how to use an Arduino, right? We learned how to use an Arduino, how to blink some lights. We learned how to move a motor, and so we've done this. Do you guys remember that? And actually, this machine is basically like a super powerful Arduino, and it's also cheaper. So actually, it's a very interesting device. And what we're going to do is that if it sees a face, I'm going to ask it to actually point the fingers at the face. So imagine that this here, this servo motor, is a little hand, and it's pointing at the face. And if my face moves from being in the middle of the image but goes to the left, the finger is going to point on the left. If my face goes on the right, the finger is going to point and follow me on the right. So this is what this little piece of software is going to try to do. And so that's the finger, that's the brain, that's the hands. Okay. So what I'm going to do, instead of loading this Arduino code, I'm going to load a small Python script, which is going to try to see not if I'm smiling, but where is my face in the screen. If it's the screen has a value of 0 on the right and of 1024 on the left. So if I'm around 500, if I'm in the middle, it's going to know, okay, you're in the middle, good, I don't need to move. But if I start to move away, say 100 points, so if I go less than 300 or more than 600, then it's going to try to go left or right. Yeah? So these are the commands. So the command for me here, I need first to stop the previous, so the current software is called Joy Detection Demo. So that's the name of the current program that is running. So the first thing I need to do is I will need to tell it to stop, because I don't want to to run multiple programs at the same time. I want to run just one, otherwise it might become very, very confused. So the first thing I need to do is to tell it, please stop detecting a joyful face. So in the Raspberry Pi language, it's sudo, means I'm the boss and you're going to listen to me. I'm going to give you a command right now. System control, I'm going to give you a system-wide control information. I'm going to ask you to stop, and I'm going to ask you to stop the demo that detects the smiling face. So that's the command line that I should enter. And now I want to track.python. So I want to run this small Python script. And to run the small Python script that is here is this one, Python 3. So it's a Python 3 means run Python 3, the software. And you're going to be using Python 3 as a tool to run track.py. So I'm just going to take that command line here. Here. So track.py. Where's my window? Did I close it? Uh-oh. Where did I should be here. Okay. So I'm going to say Python 3 track py and enter. And now it's going to call this script that we wrote. It's going to take a second or two. And now it's started running it. So now the camera is running. And I'm going to try to find your face. As soon as it finds your face, you see it's going to print. Oops. Maybe I will just hold it like this. It'll be a bit easier. Okay. I'm just gonna hold it like that. Okay. So I'm filming your face, and you can see that the face right of center. Can you get your face so it's in the middle? So if you are managing to get your face right in the center, maybe I'll move the camera. Okay. Your face in the center of the image, and you can hear the motor has stopped shifting. If I shift the camera a little bit, then it says, oh, your face is right at the center. If I move the camera, it says, oh, okay, your face should be left Oh, maybe I'm
That's
Is
all
in
left.
center.
left, right. So basically what it's doing is that it's locating in your faces. Okay, so based on this, now you understand you can detect a face, so you could detect a sound, you could detect a posture. And based on that, if you want to stop what the process is happening, you do Control-C, and it's gonna be stopping what's happening there, and then you can start again the other program. It's almost the end of the class. I'm gonna move forward and show you a few more things before we run out of time. Okay. So the reason why I'm showing to you this is because, for example, like I found some examples of people who did a small dinosaur. So you could make, say, a small dinosaur that could follow a person's face. So let's say instead of having just a webcam at home, we could have a small dinosaur, and the dinosaur would be carrying or hiding, concealing a camera inside, and it could follow the people around inside of the room, for example. So this is the one that I built. Or for example, let's say if you wanted to build a car that follows a particular person, then you could actually just put this on top of a car, and instead of just controlling the movement to have a finger, you could actually change the position of the wheels. And then suddenly you would have a car that follows a particular person. Or it follows a person when this person has a particular expression. Or this one, which is one of my favorites, you could actually use this camera as an image classifier to recognize insects. So for example, I could put this camera here and stick it like this, and I could show it an insect on my book, and it would tell me, oh, I have 80% confidence that what you're showing to me is a Glaucuriosa fastuosa. Because actually there's a community called iNaturalists, which is a community that studies biology. They're basically citizen scientists, people just like you who go outside and they take thousands of pictures of insects in the streets, and then they add it to a catalog, and they have biologists who actually say, oh, I know this insect, and they will put the name of it. And they have made all the database to be all open source. So it means that basically they have trained a very, very large data sets to recognize insects. So what you could do is that now you could use even a simple camera like this, and you could go out and use this to recognize insects. And then if you are more entrepreneurial, you could actually write a simple iOS or an Android app and sell the service of classifying insects. And people who, you could sell this app that you build, you could sell it for a few dollars. You could use something that's entirely free and just repackage it, give it a nice skin, maybe make it easier to use, and you could be making a business out of it, for example, as a designer or as an entrepreneurial designer. And a lot of people are doing that nowadays. So a lot of stuff is free, but you make it a bit more easy to use, and then you can charge people to do that. So the particular application of it that I'm most excited to do, in my case, is how to map coral reefs. And same for coral reefs. So this is the robot that actually Michael here is helping to build. So this is the robot that we're building. It's taking pictures of coral reef. And so if we can take pictures of coral reef, and we have this robot sailing around Hong Kong, taking thousands of pictures of the ground, eventually, if I have trained it just enough so they can recognize, oh, there's something, or there's a feature, there's this coral. Imagine if this can drive around and take pictures of coral, then once it's got those pictures of corals, and if I take those pictures of corals and I give it to a scientist in Hong Kong, and the scientists help me to tag those images, and they say, I know this coral is a brain coral, or this is a soft coral, or hard coral at least. They give me just some information. Then over time, if I have this boat that has solar panels and just transmitting data, it's just going to learn about coral by itself and just improve and give me more and more accurate data. And if you feed it even more precise data like 3D sets images, so not only like the just 2D images, but 3D images, then the rate of which it's going to be able to identify is going to be extremely high. Okay, so I highly recommend you to watch this TED Talk for designer. I think it's really amazing. It shows at Autodesk they have a bunch of different projects where they use not only 3D modeling software, but they basically put AI inside of the 3D modeling software, not only to learn about objects, but to generate objects. And that goes from So if you watch this talk, it will show you, for example, you can use AI. In this case, they are modeling here. It's a car chassis. So here, what they did is that they just told the Fusion 360 or like a similar version of that. Okay, the car when we're driving around has stress in this location. So there's more vibration in this part of the chassis. And what the computer did is like, okay, you need to attach 4 wheels together and you need to have that much space in the middle. And I'm just going to generate millions of different car frames. And I'm going to then run different mechanical simulations on those car frames. And it will basically choose which one have better characteristics for each. So it's going to say, okay, if I was driving from Earth to Mars, like 1,000,000 times, and I have very different conditions, then these are the kind of chassis that would look like. And what's really crazy, it turns out it looks really very much like bones, basically. So the best, like bones are actually without intelligent design, just through evolution, has developed into this kind of optimized shape. This is another design they're working on with Airbus. And so this would be like an optimized way to have the largest viewfinders or windows, and at the same time, the lightest structure. And this is also like the lightest section from an airplane. If you need to put reinforcement in an airplane, this is how it would look like. There will be significantly less amount of material. It doesn't have to be all optimized. You could also optimize part of the system and use whatever is easy for you to fabricate. But they use that you know about chess players, you know about like the sci-fi stuff, but they use this to for example, to also, this is very interesting, where they have architecture projects where you have AI controlling humans. So this time you have AI telling you, we need to build this building, and the fastest way is going to be that agent Chiki is going to catch that brick number 164, and you're going to be catching brick 165, and you're going to be moving in that pattern, basically. So you can also like revert the roles, and you can get AI not to be just on the computer, but also to use humans as agents or actuators, if you will. For example, this is another AI that basically builds the bridge that supports the robotic arm. This one is so basically he shows a bunch of projects of how you can get AI to do really amazing things, like driving cars and learning from the best like stunt drivers to perform further stunts. So I recommend you to watch this talk. I think it's really fascinating work that they're doing. And these are the millions of iterations they do to optimize the structure of a cart. So on the Google experiment with Google, they have this gallery where they show different things that they have done with AI.
General speech recognition, but if you do not stand as most of people, it will not understand you.
No one's ever collected large data sets of people whose speech is hard for others to understand.
People who have multiple sclerosis, or GF, who have stroke, who stutter.
They're not used in training the speech recognition models. The game is to record things and then have it recognize things that you say that aren't in the training set. Dimitri recorded 15,000 phrases. It wasn't obvious that this was going to work. He just sat there and he kept recording.
We need to make all voice interactive devices be able to understand any person who speaks to them.
You can see that it's possible to make a speech recognizer to work for Dimitri. It should be possible to make it work for many people, even people who can't speak because they've lost the ability to speak. The work that Shanxing has done on, voice utterances, from sounds alone, you can communicate. But there might be other ways of communicating.
Most people with ALS end up using an on-screen keyboard and having to type each individual letter with their eyes.
For me, communicating is slow.
Steve might crack a joke related to something that happened about in his tool so that Steve can train machine learning models his style to understand his facial expressions. To be able to laugh, to be able to cheer, to be able to boo. Things that seem maybe superfluous, but actually are so core to being human.
I still think this is only the tip of the iceberg. We're not even scratching the surface yet of what is possible if we can get speech recognizers to work with small numbers of people who learn lessons, which we can then combine to build something that really works for everyone.
To understand and be understood. The effort on doing your work.
Okay, so actually if you go on this webpage for Experiment with Google, there's a lot of actual product designers, just like yourself, who are using those libraries that we experimented with, and they build some works of art with it, or they can make a musical instrument based on this, or they train to train basically the Google to interact with more people. I'll just give you one example. Actually, there's no time, so I'm just gonna go faster. So it doesn't have to be mechanical actuation or LED or robot, but it can also be as more subtle. There's also chatbots. So for example, now and increasingly in the future, when you're going to be calling, say, for having information about the shop, instead of having a human being telling you tomorrow we're going to be open at 5 o'clock, you're going to have a digital voice and a chatbot just giving you this information. It's going to understand what you're saying instead of typing it, and it's just going to answer to you in a way that I think in a couple of years you won't be able to really tell the difference. These documents are absolutely beautiful. This one is how a human brain function, and this one is how the collective brain function. This is a data visualization made by a friend of mine. His name is Mauro Martino, and he represented the connection between all the scientific papers published in Nature, in Nature.com, the publication, and it shows basically how human brains function together, or how science functions through connections. I've selected the numbers of talks. I wonder where this note came from. Okay, I selected a number of talk. These guys, all these are really fascinating. So if you have some time, I really recommend you to watch them. Also, this book is 100-page where it teaches you in much more depth, but still manageable, like in 100-page about machine learning. You could buy the ebook, or you could just read it for free on the GitHub. The author, of course, is Computer Geek, so you could read it all on GitHub on Dropbox. And so what next for us? Okay, so that's the really exciting part. So do you guys remember we went to see an exhibition about 3D printing in space? Everybody was there, right? So I have a really, really good news about this. Actually, Eric has given us the green light to go ahead, and next semester, representation course, we're actually going to be printing. We're actually going to be designing and building to actually be basically be 3D printing in space. So so that's really huge. That means that in the last few weeks, I've been working very hard to make this connection. Michael as well actually helped to make the presentation, and we've connected with some experts who are like robotic arm, like people who design robotic arm to print data. We talk to make agricultural machinery. And we speak to like computer scientists, or we speak to a bunch of people basically that would enable us to next semester do this kind of design and technology development. So next semester we're going to actually be building like space printers. So I'm going to give you some examples of AI that we're going to be using in the next semester. So these are just examples that I just kind of came up with, put up of my imagination. The first is if we are, for example, making a robot that moves around and that has AI, and we use this AI to decide where is the best place to build a house, for example. So that's AI for exploration. Whether is the terrain even, for example, Or are we on a side slope of a mountain? Maybe a side of a mountain is not a very convenient place to 3D print a house. Or second, AI for fabrication. When you are a chaotic environment, a 3D printer, which has just like an XYZ kind of control, may not cut it. Because on Mars, the temperature changes so much. Because temperature is so extreme, very cold and quite hot sometimes. How do you deal with this variation in temperature? If you're 3D printing, which is typically a thermal process, how do you deal with the changes in temperature? So you can't just assume that you're XYZ, and when you finish a rotation, your point is going to still be there. It probably would have changed because one side is drawing faster than the other side, for example. You would have to adjust constantly your machine. The third example is how we're going to even develop materials for Mars. We have very few samples of, we don't have samples of Mars regolith. We have observed it from far away, so we have an idea of the chemistry of it. But if we want to be ready to any possibility, by the time we send astronauts there and spend trillions of dollars to get there, we actually want to know what are the different possibilities. So we want to test many different chemical bonds. We want to test different chemical mix, basically. And so if there are millions of possibilities, then maybe it's too long to do it in the lab. Maybe it's faster to simulate the different mixes that are possible. Or for example, if we have to grow, now the best hypothesis is that we'll take the dust from Mars and then we'll mix it with algae that we will grow in the space station. And that's fine, but which algae, for example? And how many percent? And how much water do we need to put in the mix? Or do we put water at all? So all these questions need to be answered. Or for example, when we get to Mars, which plant is going to grow better in lower gravity? So if we can use AI to optimize that, or if we want to, because genetics is also such a huge data set, it's impossible almost to make sufficient numbers of experimentation to know which plants are going to be the best suited for Mars climate. Also, what kind of behavior should we have if we build a new society, new social settlements? The systems of politics and democracy that we assume on Earth, is it going to be the best suited for this new environment? There's no way to really know about this. Could we experiment different types of governance and human behavior in this type of new environment when you have just a few people? It may be a very different way to optimize that. So these are the people who are currently interested in joining the project. So you have, so NASA will be the ultimate client. So if we guys work really hard, it's possible that we can present our findings to some scientists at NASA. So we are getting in touch with those people who are building the 3D printers for space. Our intermediary right now is the AI Space Factory. So this is a New York and Shanghai-based architecture firm that won the last competition for the NASA Sentinel Challenge. And we, HKU will be the main vessel. We have a number of other universities that are interested to join in this effort. So we're trying to coordinate with them and make a day that would act as a kind of central hub to coordinate. These are the people that are currently on the program. So there's the NASA, the program manager for the NASA Sentinel Challenge. So she is the one who organized the competition and tried to define the criteria for finding which has the best chance of printing on Mars. Then you have David Mallet, who is the Asian American architect. Actually, he designed the ICC, and he's also the head of AI Space Factory. And so he's the guy who is going to be our point of contact to NASA. There's a number of other people in the AI Space Factory that I think we'll be talking to more frequently. Then we have, obviously, the head of architecture for HKU, Lydia, myself. So Marcin is a fascinating guy. He's a Polish nuclear physicist originally, but now he focuses on digital fabrication and agricultural machinery. So he has a farm in Missouri, and he's building all sorts of crazy machines to work the fields, which is great because he knows very well how to build heavy machines. Hema Philamor was supposed to be the speaker last week, but it was canceled because of the protest, but she builds those autonomous robots. And Alvaro Castanelli, he's a professor of applied mathematics and computer science at CEU and a good friend of mine. And I hope he's going to be involved as well. Okay, so because we already passed the deadline, this is your assignment. So it's going to be simpler. I'm going to ask you to do So today we played with teachable machine, right? We learned how to put an object in front of your webcam and how to build data sets. I'm going to ask you to play with the system, either with the image, with the audio, or the post project. That's the basic. And if you are good at it, then you could also go further. But the minimum thing that I'm going to ask you to deliver for next class is at the beginning of next class, I'll ask you to demonstrate that you have trained a data set. And so you will have to show me that you can basically recognize different types of objects, or different types of sounds, or different types of poses. Yeah? So you basically need to go on the websites and train a bunch of data sets. And I invite you not to stick to the basic that I've just showed you today, but to go a little bit deeper. Maybe recognize more different objects, or try to find a point of equilibrium where you recognize 50%, 50%, 2 or 3 different types of objects. Or you could try to build something like this that I have built if you're interested in doing so. And so I will ask you to do that, and then to tell me, also have just an idea, just to start thinking, if you were in a different planet, what do you think you'd be using AI for? So I showed you some different examples that I came up with. So exploration, fabrication, chemistry, biology, plant growth. I showed you synthetic biology, like organism development, or like human behavior development, curation, if you will. And so the assignment is that 1, you will train a data set, and that's completely separate from exercise 2. It's just to think, okay, if I was on a different planet, what would I be using AI for? And so that's basically 2 small exercises. And I'm going to ask you to record a video of yourself, just a 1-minute video, because a lot of you maybe are not here in person, so you could see that you, 30 seconds, show me the set that you have trained. And second, you tell me what you imagine you could use AI in outer space for. Just a 1-minute video. If you come in person, you could also show it to me. But because a lot of you are remote, then it would have to be YouTube unlisted. Do you have any question on how to do this assignment? So we'll start next session. You show me, you demonstrate the classifier, and you tell me the idea of what we could use AI for in outer space. Okay, so to close, so now you had this 2-hour introduction to AI for Designer. Who feels, do you feel different, or do you feel the same as at the beginning of the session? So who was it the first time you actually built an AI? Did you actually make something with AI before? No? So who did something with AI? So everybody's the first time. What's your impression of using and building a set?
It's cool.
Did you find it difficult?
Because we could use something simple and make it a very sophisticated device. And we can identify like there's inside it's very complicated.
The interface can be simple, even if the process inside is complicated, right? Yeah. What is your impression?
I'm thinking about programming lesson I had in secondary school. I think the final kind of project is building kind of an app which learns how to play something. But I forgot about the details because we're working in groups, but I think it's still interesting. But I'm not sure about the fearful side of AI. That will something turn wrong. Yeah, I think I'm about neutral still.
What's your impression after that?
So neutral to AI, but also maybe helps the stage that humans can process or understand what it's learning itself.
Okay. Do you so in the group online, do you have any question on how to complete the assignment?
Those 2 contents are within 1 minute.
Yeah, if you want to
1 minute for each.
Either way, 1 minute for each is also fine. But I think if you have a classifier and you show me like I can recognize this and I can recognize that, I don't think we need a full minute to do that. Yeah, ideally Yeah, if you need 2 minutes, that's also fine.
For the second part, do we just like talk about it, or do we need to?
I mean, that would be super fun. For example, like let's say if you build something. So let's say if you say that you want to build an AI that can recognize aliens, and your classifier is your face, and then you take like an alien picture, and you say that what if I put this AI on a rover, and if it sees an alien, it would recognize an alien, and you'd have answered both of the briefs at the same time. Do you know what I mean? It could be like, oh, I made a classifier of human beings and aliens, and that's my idea. Like, I suppose like if you could use an AI to recognize living form on another planet, that'd be a cool use of AI. You know what I mean?
Yeah.
Any other questions? So for the next session, so for the 26th, the last course of the semester. So next class, you'll need to come with your laptop because we'll do some web development and UX UI. So basic web development and basic like app development. So please bring your laptop because I will show you a bunch of things on the laptop. Any more questions about the assignment?
No.
Okay. Cool.
Right.
Thank you, everybody.
Yeah. Thank you.
Thank you.
Bye-bye.
Yeah. Bye-bye.
Bye.